Right. Today we are starting a lecture on the basis of very basic concepts related with the cardiovascular system, right? Especially the histology of cardiovascular system and very basic anatomy of cardiovascular system, right? What is the very basic function of cardiovascular system? Yes, ma'am? This is simply a transport system. Cardiovascular system is basically a transport system, right? And it is supposed to transport the nutrients to the tissue. It is supposed to transport the white blood cells and antibodies, which are the components of the immune system, to the tissues, and it is supposed to transport the hormones, right, to the tissue, and from the tissue it transport away the metabolic waste products, right. And this system consists of one pump, that is called heart, and a closed vascular system through which blood is circulating. So let me draw that. First of all, I will draw the left side of the heart. Now, this is the left atrium, right? Blood from the left atrium goes to the left, yes please, ventricle, right? And blood from the left atrium to the left ventricle passes through which valve? Which valve is here? This is mitral valve, right? This is left side of the heart. So on the left side of the heart, blood is initially received in the left atrium. From the left atrium, blood goes to the left ventricle through the mitral valve, and when left ventricle contract, it pushes the blood into aorta, not pulmonary artery. It pushes the blood to, yes, aorta, right? So this is the left side of the heart. And if we look on the right side of the heart, the blood is coming from the body, right, through superior vena cava and inferior vena cava. Blood is coming from the body to the right heart, the venous blood. And in the right heart, it is coming where exactly? What is this? Right atrium, right? And from the right atrium, it passes through this valve. And what is the name of this valve? Yes, tricuspid valve, tricuspid valve. And through the tricuspid valve, it is going to the right ventricle. It is going to the right ventricle. And from the right ventricle, it passes out into, yes, again, blood is coming from all over the body through the superior vena cava and inferior vena cava, through the right atrium. From the right atrium, through the tricuspid valve, it comes to the right ventricle. From the right ventricle, it is going out through, yes, pulmonary artery. And while it is going out, it has to pass through a valve here. And what is this valve? Pulmonary valve. Is that right? Again, I will draw these components separately. Now you have to tell me. First I will draw the left heart, then I will draw the right heart. Now you will tell me, the left heart, what is this component? Left atrium. What is this valve? Mitral valve. What is this? Left ventricle. And what is its outflow? Aorta. Is that right? Outflow is aorta. Now I am going to draw the right heart. Right heart is, input is superior vena cava and, yes please, inferior vena cava. They bring the blood to right, yes, atrium. From the right atrium, through which valve it is going to the right ventricle? Tricuspid valve. And from here it is going out into pulmonary artery. Now the input valves are, on the left side, the input valve is input to the ventricle. The valve is mitral valve. On the right side, the input valve is, yes, tricuspid valve. So we can say, as far as the ventricle are concerned, mitral valve and tricuspid valves are the input valve. Is that right? And on the left side it is mitral valve, on the right side it is tricuspid valve. Is that right? And why we call it tricuspid valve? Let's have a look on this valve. If you look at the valve, you are standing yourself here and you look down on this valve, right? It has 3 cusps. It has 3 leaflets. Because it has 1, 2 and 3 leaflets, that is why this valve is called tricuspid valve. Mitral valve has 2 leaflets. 2 leaflets, anterior and posterior. That is why mitral valve is called also bicuspid valve. Is that right? Because bicuspid valve or mitral valve and tricuspid valve are between the atria and the ventricles. So they are also called atrioventricular valves. What are they also called? Atrioventricular valves, because both of these valves are between the atria and ventricles. Is that right? So these are the, you can say, input valve into ventricles. Then what are the output valves? Output valve, from the left ventricle, blood is going to aorta. So valve which is put over here, this is called aortic valve, right? And the valve which is from right ventricle to pulmonary artery, this is called pulmonary valve, right? From the right ventricle to pulmonary artery, right? This passage is having a valve called pulmonary valve. So output valve from the heart are aortic valve on the left side and pulmonary valve on the right side. Any question up to this? Now I will rapidly draw the basic structure of the heart and you have to identify the structures. I will see that I can draw it fastly or you identify it fastly, right? Okay. Yes, what is it? Right atrium. What is it? Tricuspid valve. Yes? Pulmonary valve and pulmonary artery. Now we'll draw the left structures and you have to be more rapid. You're not that fast. What is it? What is it? Right? It is left. It is left atrium, left ventricle, mitral valve, aortic valve and aorta. Is that right? No problem up to this. This is the main, you can say, main structure of the heart, right? Now let's put both left part of the heart and right part of the heart in perspective with the vascular tree, right? That what is the relationship of whole cardiac structure with the vascular connections. I hope you identify this structure now. I hope you understand this is aorta. Now what really happens? All the blood from the body is coming through superior vena cava and inferior vena cava to the right atrium, and through the tricuspid valve it is going to the right ventricle. From the right ventricle it is pumped into pulmonary artery through the pulmonary valve. Now from the pulmonary valve, where the blood goes, right? This is going to the lungs. The blood is going to the lungs. Right, of course, you know there are 2 lungs, there is right and left, but I will just draw one lung, right? And what really happens, that pulmonary artery, right? Pulmonary artery divides into smaller branches as it reaches lung, and of course it goes into smaller branches, smaller pulmonary artery, then eventually pulmonary arterioles, and here are your air pockets. Let's suppose these are your air pockets. This is representative of, this is a very simple diagram, and the blood will pass through pulmonary capillaries, right? Pulmonary capillaries. Okay, I'll make it with different colors. So these are pulmonary capillaries, right? And gas exchange will be here, and then well oxygenated blood from the pulmonary system will come to, yes, where? To the left heart. Now this part of circulation, the circulation, listen carefully, the concept is the circulation between the right heart and the left heart. The part of circulation is called pulmonary circulation. Pulmonary circulation is the part of circulation between the right heart and the left heart, right? That pulmonary artery taking the blood to the lungs. What is it? Pulmonary artery taking the blood to the lungs. And then pulmonary arterial tree break down into pulmonary, yes, what is it? Pulmonary capillaries, right? And through the pulmonary capillaries, you must be knowing that carbon dioxide is lost to the lungs and oxygen is gained, right? So what really happens, that pulmonary arterial tree, as it passes through the lung tissue, it breaks down into smaller arteries until the smallest arterioles break down into capillaries, which are pulmonary capillaries. And pulmonary capillaries are the area where gas exchange will occur between the air spaces and the vascular system. Is that right? Carbon dioxide will be lost to the lungs and oxygen will be picked up by the blood, and then oxygenated blood will move to the left heart. This is oxygenated blood coming to the left heart, and this oxygenated blood which is coming to the left heart, of course it is draining into left atrium. Now what is this vessel which is bringing the blood from the lungs to the left atrium? What is the name of this main vessel? There are basically two vessels from the each lung. So there are four, two from the left side and two from the right side. So basically how many openings are there? And four. What are these? These are called pulmonary veins. What are these called? These are called pulmonary veins. Important point which you have to remember is that pulmonary veins are having oxygenated blood. Is that right? Pulmonary veins are having oxygenated blood. So what we can say, left atrium is receiving the blood, oxygenated blood from the lungs. Left atrium is receiving oxygenated blood from the lungs through pulmonary veins. Is that right? Now, blood comes to left atrium. Then you know that from the left atrium it will go through which valve? Yes, mitral valve, and this oxygenated blood will come to the left. Yes, ventricle. From the left ventricle, blood will be pumped into, yes, aorta. And when blood is going to aorta, between the left ventricle and, yes, aorta, there is another valve here. What is the name of this valve? Aortic valve, right? And then blood will come to the, yes, aorta. And this oxygenated blood, when it's passing through the aorta, naturally aorta gives its branches. Is that right? And this is called systemic arterial tree. First there are large arteries, aorta and its main branches are called large. Of course these are systemic artery. Large systemic arteries, aorta and its branches. Then naturally from this there will be smaller, medium sized arteries will be there. Let's suppose this is a medium sized artery, and medium sized artery is also called muscular artery because it has lot of smooth muscle, and large arteries are having lot of elastic tissue, so they are also called elastic arteries. So from the left heart, blood is pumped into aorta and its main branches, which are elastic arteries, and from the elastic arteries blood goes into medium sized vessels which are called muscular artery, and from there to smaller arteries, and eventually for very small arteries, and which are called, yes, arterioles. Arterioles. These are very small, right? Large arteries are usually more than 1 centimeter in diameter. Large arteries are usually more than 1 centimeter in diameter, right? And these arteries, which are called the medium sized muscular artery, their size is smaller, and they are somewhere between these medium sized arteries. These are smaller, they are somewhere between 2 to 10 millimeters, right? And then arterioles are very small, then smaller arteries and arterioles are very small, they are about 0.1 to 2 millimeter. There is no need to remember these sizes, but the very important point is that blood is moving from the left ventricle into aorta and its main branches, which are called elastic arteries, then into medium sized arteries, which are called muscular arteries, and then small arteries, and eventually into arterioles, right? Then, for example, this is a tissue in which this blood supply is coming. Now, arterioles break down into further small vessels, which I will explain later, which are called meta arterioles. I will explain them later. And then these meta arterioles break down into very, very small vessels, which are called, yes please, capillaries, right? And these capillaries come together, right? Now these capillaries are the exchange vessels, because here are your tissue cells. Now through the capillaries, oxygen will come to the tissues, amino acids and glucose will come to the tissues. If there is a need, then white blood cells or antibodies can come to the tissues, hormones can come to the tissues, and from the tissue, waste product like carbon dioxide and other metabolic waste will go back to the circulation. Then from the capillaries, right, it will drain into venules. What are these? Venules. And venules will go into small veins, right? They will drain into small veins. These are venules. Venules into small veins, and small veins, many of the small veins will eventually drain into, yes, large veins. And large veins will eventually drain into, yes, cava system, either inferior vena cava or superior vena cava, and blood will be now coming back to the right heart. So let me tell you again that right ventricle pump the blood to pulmonary arterial system. Pulmonary arterial system takes the deoxygenated blood to the lungs. In the lungs, through the pulmonary capillaries, blood gets oxygenated. Then oxygenated blood goes to pulmonary veins, right? And from the pulmonary vein, taking the oxygenated blood from the lungs to the left heart, into left atrium. Blood from the left atrium passes through the, what is this? Mitral valve to the left ventricle, and from the left ventricle, blood is pumped through the aortic valve into aorta. Aorta and its major vessels are called, major branches are called elastic arteries. So blood from the major large size arteries or elastic arteries goes into medium sized arteries or muscular arteries. From there it goes to arterioles, and then another exchange area from where substances can be exchanged between the blood and the tissues, right? That area is capillaries. And capillaries are so thin walled that there are easy exchange of material between the tissue cells and the blood, right? So oxygen is given to the tissue, amino acids, glucose and hormones, and if antibodies are required, right? So these substances which are required by the tissue shift from the blood to the tissue cells, and from the tissue cells carbon dioxide and waste products come into capillaries back, and these capillaries blood will move to the venules, then into small veins, large veins, vena cava, and back to the right heart. In this way, basically your whole circulation can be divided between the circulation between the right heart and the left heart, and then circulation between the left heart and the right heart. The component of circulation between the right heart and the left heart, this part of circulation is called pulmonary circulation. Pulmonary circulation, right? And this part of the circulation which is between the left heart and passes through the all body and comes back to the right heart, this is called, yes, systemic circulation. Systemic circulation. And what was this? Yes, pulmonary circulation. Is that right? So basically you have primarily in the body two types of circulations. There is pulmonary circulation and there is systemic circulation, right? For example, blood which is passing through your kidneys, that is part of systemic circulation, right? Blood which is coming from passing through the GIT is systemic circulation. Blood which is passing through these muscles is systemic circulation, because blood which is coming to all these tissues is actually coming from left heart and aorta and its branches. Am I clear? Right? Now, again, I will make the whole this diagram in a simple way, and now you have to recognize these structures. It's a very, very simple lecture, right? Now I will, even though right and left heart are together, but I will draw them separately for convenience. Now here I am going to draw the right heart, and here is your, of course, pulmonary system. Here I draw one lung, and here is, suppose, your left heart. Now you have to tell me the components of the whole circulatory system. Look, yes, all the blood from the body is collected from superior vena cava and inferior vena cava to the right atrium, then through which valve? Going to the tricuspid valve, coming to the right ventricle. From here it is passing through another valve. What is this valve? Pulmonary valve. Going to which artery? Pulmonary artery. Now here you have to understand it, that here are your, I have drawn only one lung. Suppose these are the air pockets, right? Alveolar. Now this, from the pulmonary artery the branches will come, right? And these branches eventually become very, very small vessels, and the vessels become so small and thin walled that gases can be exchanged between the airspace and the blood, right? And you know that from here carbon dioxide will go to the air spaces and oxygen will come to the blood. Is that right? Now we have to, and eventually oxygenated blood will move from the lungs to the where? To the left atrium. Now listen. Here is the beginning of the pulmonary artery, right? So this becomes your pulmonary artery. They break down into smaller branches until, what is this here? Pulmonary capillaries. And then there is pulmonary vein, right? The point which you have to remember, from pulmonary artery, right, which is starting from the right heart and end of the pulmonary vein up to left atrium, this circulatory system is called which circulation? Pulmonary circulation. What is it? Pulmonary circulation. Am I clear to everyone? Then oxygenated blood is coming to the left heart. Yes, now you will tell me. It is coming to the left heart. left atrium, then into, through which valve? Mitral valve to the left ventricle. From there passing through which valve? What is this valve? Aortic valve into aorta, and now it is from here, aortic valve and onward. This is the beginning of systemic circulation. What is it? It is the beginning of, from aortic valve and onward, it is the beginning of systemic circulation. And blood is passing through. Why we call it systemic circulation? Because this vascular system is taking the blood to the many systems of the body, like renal system, gastrointestinal system, right? Like musculoskeletal system. So it is called systemic circulation. From the systemic circulation, now we can put the tissues, like we can put the GIT here. Okay, there is liver also here. We can put your beautiful kidney over here. Maybe we can put some muscle here. Now the perspective you have to develop is that there are major from elastic arteries, then there are going to be medium sized artery, and medium sized artery will take the blood to the tissues, right? Again, and this vessel is medium sized artery. This will break down into what? Yes, please. Arterioles, very good. And arterioles will break down into what? Meta-arterioles, and meta-arterioles will eventually break down into what? Capillaries, and capillaries will collect into, yes please, venules, and venules will collect into small veins, and small veins will become part of large veins, and large veins will drain into cable system. Here inferior cable system, the blood which has gone to the upper part of the body into superior cable system. Right. Now what I have said, where is the beginning of systemic circulation? From beginning of aorta. This is the systemic circulation and passing through different tissues. And eventually, where is the termination of systemic circulation? When blood from superior vena cava and inferior vena cava drain into right atrium. So what we can say, as I said in the beginning, that between the right heart and the left heart, there is pulmonary circulation. Between the left heart and the right heart, between the left heart and the right heart, there is systemic circulation. First, this concept should be clear. If it is clear, then we talk about few more important things. Pulmonary circulation is intimately related with the lungs. Systemic circulation supplies the blood to multiple systems of the body. Is that right? Then pulmonary circulation is a smaller circulation and systemic circulation is a larger circulation. Then pulmonary circulation is low pressure circulation. We don't want very high blood pressure here, right? Low pressure circulation. This is high pressure circulation. So how many differences you know now between the pulmonary circulation and the systemic circulation? Yes, who will tell me? Number one, start with it. Number one, pulmonary circulation is between right and the left, and systemic is between left heart and the right heart. This is difference number one. Yes, then difference number two, pulmonary circulation is involving mainly lungs and systemic circulation is involving multiple systems. Difference number three, pulmonary circulation is smaller circulation and systemic circulation is larger circulation. Number four, pulmonary circulation is low pressure circulation and systemic circulation is high pressure circulation. Difference number five. Yes, who will tell me? In pulmonary artery, there is deoxygenated blood, and in pulmonary vein, there is oxygenated blood. But opposite is true here. Here, the systemic arteries have oxygenated blood, and systemic veins have deoxygenated blood. Is that right? So this is another difference. Any more difference? Yes. Any more difference? Size we have discussed. Yeah? Okay, he wants to say, she is just trying to make one more difference. He is saying that this circulation is bringing oxygen and taking the carbon dioxide to the heart, and of course we have discussed, and pulmonary circulation is bringing the blood which is loaded with carbon dioxide to the lungs and taking the oxygenated blood. Okay, I think before you start telling me funny things, we go to something else now. right? This was the very basic idea about the circulation, right? Now we will go into detail of heart. First we will discuss heart into detail, then we will discuss major arteries, medium sized arteries, small arteries and arterioles, then we will discuss capillaries, and eventually we will come to the venous system. Before we really go for that, somewhere in the body, in some parts of the body, circulation is little bit altered, because common theme is that arterial system should bring the blood to the tissue, then there should be capillary exchange area, and then venous system should be the drainage. This is what is happening in most areas of the body. But some parts of the body, circulation is not following this simple rule. What is the simple rule? Systemic arteries bring the blood, then there are systemic capillaries, and then blood drained by systemic veins, right? Now, what is the normal? Artery, capillary and vein. This is a normal arrangement, right? In some part of the body it is changed. For example, from aorta by arterial system, blood is brought to GIT, right? When blood comes to GIT, this is the arterial blood which is coming to GIT. Then within the GIT lining, it breaks down into smaller capillaries. It will break down into, yes, what? Capillaries. And then these capillaries will unite together and make a vein. Now up to now it looks like normal system. That arterial system is bringing the blood. Within the GIT there is breakdown of arterial system into capillary system, and capillary system reunite to make venous system. Up to now it looks like normal standard thing. Of course, why there are capillaries here? From the GIT they will absorb the glucose and amino acids and other nutrients. Normally veins should go eventually into progressively larger veins than vena cava, but here there is a modification. This vein will go to the liver, and in the liver it will again break down into, yes, capillaries. It will again break down into capillaries, and these capillaries will again come together and make another vein, and that vein will go and drain into caval system. Now this is a modified circulatory pattern, right? What is this modification? That between one capillary set, attention please, between one capillary set and the next capillary set, there is a vein in between, right? This type of modified system is called, who will tell me? Where one capillary set, one capillary set which is receiving the blood from arterial system goes into vein, but vein is not progressively going into larger vein. This vein again break down into another set of capillaries. You know why this special arrangement is there? Because glucose and amino acids which are taken from the GIT, they should be brought to the liver, and the liver again they break down to special capillaries called sinusoids, and there liver cell can act on the glucose and amino acids, and after that substances will go to systemic circulation. This type of circulation is called portal circulation. What is it called? Portal circulation. Another example of portal circulation in your body, another example of portal circulation, which is portal circulation means the circulation which is not following the simple rule. Simple rule is arterial input, capillary exchange, venous output. But here there is an unusual thing, arterial into capillary to vein. From here vein again break up into capillaries, and then recollection of vein, and then eventually major veins. Any other portal circulation in your body? Yeah, in the kidney. How come in the kidney? Who will tell me? What kind of portal circulation is present in the kidney? I'm about to be impressed by someone. Okay, I will make nephrons so that you feel comfortable. Let's suppose this is a very special epithelial tubes in the kidney which are busy in making urine, right? These epithelial tubes are called, yes please, nephrons. In one kidney you have how many nephrons? 1.2 million. You're a millionaire as far as nephrons are concerned, right? So two kidneys mean 2.4 million nephrons. Oh my god. So you have nephrons. Actually renal artery will bring the blood. Should I make kidney here? Okay, look, I'm going to make a nephron here, right? From here the urine will go down. Now this structure I'm drawing here, right? I've taken this kidney and put it over here. Now look, this is blood coming through renal artery which break down into smaller arteries, and eventually very small artery which supplies this part of the nephron. This is called, this artery is coming to the nephron, it is called afferent arteriole. Afferent arteriole break down into capillaries, small capillary loops of capillaries, and through this capillary fluid is filtered into this tube, and then all these capillaries should recollect and break down and recollect into which vessel? Not vein. This is unusual thing. It recollect into another artery. Now it's an unusual thing. Blood is coming through an arteriole, breaking into capillaries, and now capillaries reunite to make another arteriole. It's very unusual. Is that right? And then these arterioles, this is afferent arteriole, and this is called efferent arteriole. There's afferent arteriole and efferent arteriole. Then what happens? Again this arteriole breaks up into capillaries, and then eventually the second set of capillaries will go into venous side, larger veins progressively, and eventually going back through renal vein. So now you see, in the kidney, what is the pattern? Arterial system giving eventually afferent arteriole give this capillary bed which is called glomerular capillaries into efferent arterioles into another set of capillaries. What is this set of capillaries called? This set of capillaries around the tubule, so we call it peritubular capillaries. Peritubular capillaries, and then into eventually venous drainage system. Now this is also an unusual pattern, that here between the two capillary sets there is an arteriole. Here between the two capillary sets there was a venous segment. This is also a portal system, right? This is another example of portal circulation. Am I clear? Right? Okay. So we can make it like this, that afferent arteriole bring it here, and this is glomerular capillaries, and these capillaries come into efferent arteriole, and then second set of capillaries here, and then eventually collect into vein. Any question up to this? There is no question, everything is clear. Now we go to detail of the heart. All the cardiovascular system has basic principle in its structural arrangement. Either you talk about heart or arteries or veins, the basic structure, all the cardiovascular system is like a pipe, like a channel. In this channel, the basic structure is that, for example, you talk about artery or heart, there are three layers always. There's innermost layer, you talk any segment of the cardiovascular system. There's inner layer, there's a middle layer and outer layer. Let me tell you. For example, you take a segment of artery. In the artery has these, what are these cells? All the cardiovascular system is lined by these single layer of flat cells. These flat cells are called endothelial cells. You know it. All the cardiovascular system is lined by flat cells and flat squamous cells, so simple squamous cells, and these cells are called endothelial cells. And these endothelial cells, right, let us suppose I am making a structure of the medium sized artery, right? Now, endothelial cells are having a special layer of collagen around it on which they are resting. They have a sleeve or cover of collagen, right? These cells are resting on that. What is this called? This is basement membrane or basal lamina. What is it? Basal lamina. And then outside this basal lamina, there is another layer of loose connective tissue. What is this? There is another layer of loose connective tissue. And this layer is called subendothelial connective tissue. What is it called? Subendothelial connective tissue. So there are endothelial cells which are resting on, what was this structure? Yeah, basal lamina. Outside the basal lamina, what is this? Okay, I'll change the color of it. So just change it more clearly with red. Okay. Another connective tissue layer. And what is this connective tissue called? Subendothelial connective tissue. Is that right? Now, outside it, outer to it, there is a very special very special type of layer made of lot of elastic fibers, elastin fibers, and this is called internal elastic lamina. What is it called? Internal elastic lamina. Let's start from the beginning. What was this layer called? Yes, please. Endothelial cell layer. What was this? Yes, very good. Basal lamina. What was this? Yes, endothelial connective tissue. And around all these layers, what is this? Internal elastic lamina. What is it? Internal elastic lamina. Now all these layers together are called, who will tell me? Intima. Probably this is the layer, the innermost layer, which is very intimate to the blood. So we call it intima, vascular intima. Am I clear? Now if I draw a structure in a different way, let's suppose I'm making a structure of a section here, longitudinal section. This is circular section. What are these cells? Yes, please. Endothelial cells. Yes, now you will tell me under these endothelial cells are resting on what? Basal? Yes, lamina, this layer. Under that, what is this? Subendothelial? Yes, please. Connective tissue. Is that right? Under that, what is this? Internal elastic lamina or internal elastic membrane. So this is internal elastic membrane, right? Now if you come little outer to this, then what happens? Yes. Now this finishes the intima. Outside this, what will start is media. What will start? Media. Now media consists of, in the most of the vessels, media consists of many, yes, smooth muscles, right? What we'll really find here is a layer of smooth muscle, right? And these are the smooth muscles, multiple layers of smooth muscles, and the real thickness of this layer depends on the type of the artery. For example, now look, this is the middle layer, or we call it, what we call it, yes, media, right? This is the media. Out of inside the media, what is this layer? Whole intima. Now, media starts from where? What was this? Internal elastic lamina, right? This is the innermost area. Internal elastic lamina is part of intima, and anything which is outer to internal elastic lamina is media. Is that right? We are drawing medium sized artery, right? Now in medium sized artery, there are about 30 to 40 layers of smooth muscles which are making rings. Is that right? But composition of media changes according to the size of the vessel. I told you aorta is having elastic artery. Aorta is elastic artery. Now in elastic artery, in the media, there will be many elastic layers. For example, if it is not middle sized artery, this is elastic artery, then in every layer, what will be there? There will be layers of elastic tissue, elastic membranes, right? But because it is medium sized artery, or I must say that this is muscular artery, so media is mostly muscular tissue, lot of muscle. And in between the muscles, there is of course some connective tissue, there may be some proteoglycans, there may be some basal lamin, this collagen fibers, proteoglycans, right? These collagen fibers are produced by which cells here? In the media, there is some elastic fibers, there are some collagen fibers, and all the components of media are secreted by smooth muscles. They are mainly secreted by, yes, smooth muscles, right? This is the middle layer, and this all was inner layer. Now middle layer has outside it another covering. It has another special type of covering here. Right? Another covering, it has a very special type of covering. What is this covering over it? No, look, there is something special here which will put a boundary between the media and adventitia. If this was internal elastic lamina, this should be external elastic lamina. This should be called external elastic lamina. External elastic lamina. And this was, yes, what was this? Smooth, this, look, all these muscles, smooth muscles with it, including the external elastic lamina, both are together called media. right? So what was this? Smooth muscle, concentric or spiral. Yes, what are these? Layers, right? If it is medium sized artery, and both of them together are called, yes, what are they called? Media. Both of them together they are called media. So here, this was internal elastic lamina and these are the smooth muscles. Is that right? So what is this showing in this diagram? Yes, please. These smooth muscles are component of, yes, media, right? And then outside it, what was this? Yes, external, yes please, elastic lamina. Is it easy or difficult? Then comes the outermost layer, right? This was external elastic lamina. And then we come the outermost layer, and this is a layer of connective tissue, right? And in this layer of connective tissue, there is a lot of collagen, there's a lot of fibroblast, fibrocytes or fibroblast. There are nerves, small nerves, you know the small nerves which supply the artery. Even in this layer, there may be very small arterioles which are giving blood supply to the outer part of the artery. Because inner part of the artery can get oxygen directly from the blood, but outer part of the artery needs its own blood supply. These vessels which are supplying the outer part of the artery, these are called vasa vasorum. Vasa vasorum. Their branches may go up to the media, right? So outermost layer is a connective tissue layer with a lot of collagen and elastic fibers and fibroblasts. With that, they may have some blood vessels in that component, and these are called vasa vasorum because oxygen cannot come from inner layer up to here. So here are special blood vessels, very small. These are called vasa vasorum, which are seen only in large arteries and medium sized artery. Very small arterioles they are not seen, right? And with that, you know, there are many vessels, arteries are getting sympathetic supply. So sympathetic nerves are there, right? Sympathetic nerves are there. They are releasing epinephrine or norepinephrine, right? So major, you know, these sympathetic nerves are there and arteries are there. Even outer part of large arteries and medium sized arteries are drained by lymphatics. So even lymphatics are there. Now all this outermost cover is called, yes, it is called adventitia, right? So that is how an arterial structure is there, right? Adventitia, right? So again, and here we'll make adventitia here. Just to make a proper perspective, let's make it as circular. Yeah, what was this? Endothelial ring. And endothelial ring is on, just what is it? Yes, please. Basal lamina. And what was this around it? Subendothelial connective tissue. And now what is the structure around it? Internal elastic lamina. And all the structure up to now is intima. And then around that there is a layer of, what was this? Smooth muscle. Yeah. and this will be then external elastic lamina, and eventually outside that this will be adventitia. Yes, please. What is confusing?
See where it says sub-endothelia, because we're going inside out, you would think that sub would be inside.
No, sub mean under. Look.
Okay.
Look. This is endothelial cell which is resting on the basal lamina. Now, under the endothelial cell and basal lamina, we have a little connective tissue which is called subendothelial connective tissue. Because truly it will be like this, that this is the basal lamina and endothelial cell that's actually resting on the basal lamina, right? And under this situation, here is a little connective tissue. This is subendothelial connective tissue. And then your beloved, what is this? This wavy internal elastic lamina. These three layers, endothelium, basal, endothelium with basal lamina, subendothelial connective tissue with internal elastic lamina. All of them are here, intima. All of them are here, intima. Intima means the layer of the vascular system which is very intimate with the blood. Is that right? Very near to the blood. Am I clear? Out, so here is endothelial cells, then basal lamina, then what is this? Subendothelial layer. Is that right? Then internal elastic lamina. So basically all these are what? Intima. Then outside the intima there is media. And outside the media is again, media is present between internal elastic lamina and external elastic lamina. Internal elastic lamina belongs to intima. External elastic lamina belongs to media, and outside the external elastic lamina there is adventitia. So the real boundaries, especially in medium sized artery, boundaries are very clear. The real boundaries in three layers is internal elastic lamina and external elastic lamina. Internal elastic lamina and all the structures within it are intima, and structures outside the internal elastic lamina up to the external elastic lamina included are media, and structures outside the external elastic lamina are adventitia, right? So let's have a break.